let's try this example 2 on cystic fibrosis. So first question says identify the inheritance pattern. And then we have to calculate the probability that this individual 2-3 and 2-4 will have a child with cystic fibrosis. So let's figure out, is it autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive? How do we figure this out? Well, you could look at that little flow chart that I have, and essentially you look at the two parents that are the same. So we have two parents here that are unaffected, and they have an affected child, and a bunch of unaffected children. So we could probably zoom in. We could also use these ones too. Let's use this one though. So these two parents right there. Okay. So if this was autosomal dominant, okay, then the affected has to have a big A. I'm going to use big A's. Okay. And that means the unaffected then would have to be little a's. That's if the inheritance pattern is dominant. Well, do you see an issue here? These two only have little a's to give. So how does this one get a big A? So that means that this cannot be autosomal dominant. I think it's autosomal recessive. So let's try that. So if this was recessive, then the shaded have to be little a. Okay. If it's autosomal recessive disorder, then you have to be homozygous recessive to have the actual disorder. Okay, and then all the unshaded, the unaffected, have to have at least one big A. I'm not sure what else they have. You have to look at the offspring. So that would work. And then they have big A's, so all of these could work, right? Because all of those have to have a big A of some sort. It doesn't even matter what the second one is. And yep, they could get a big A from either of these parents. Now this one here and this one here, oops, I forgot about this one. The youngest brother. Always forgotten. This one here has to have a little a. So that means this mom has to give a little a and this dad has to give a little a. And does that work? Let's see. Yep, a heterozygote has a little a. That means that these actually are called carriers. So these parents are carriers, and you can only have carriers when you have autosomal, or actually not autosomal, but just recessive. It has to be recessive. Autosomal recessive often has carriers. That means they're unaffected heterozygous individuals. Okay, so this looks like it's autosomal recessive. Now, technically, there's one more question I need to answer before I can say it's autosomal. Recessive, sorry. It's the weekend and I've forgotten how to write on my iPad already. All right. So technically, before I can say this is autosomal, it's definitely recessive. Autosomal, though, I should check to see if the males and females are equally represented. So I have a female, 1, 2, 3. Okay, and males, 1, 2, 3. If there was substantially more males than females that are affected, then I'd be like, it's probably X-linked. But no, they're pretty equal. So I'd say this is autosomal recessive. Okay, now I need to calculate the probability of, let's see, 2, 3. Okay, 2, 3, that's 1. This is generation 2. 1, 2, 3. So 2, 3, this person here. Okay, and 2, 4, that's this person here. And we want to see what's the chances that they will have a child with cystic fibrosis. Okay, well, now that I have the genotypes of those two, I could do a Punnett square, right? So cystic fibrosis, remember, that's going to be a little a genotype. Well, if this parent here, 2, 3, has a big A or a little a, they can give their offspring, and this father here has a big A or a little a, then it looks to me like it's going to be a 25% probability, but let's just check. Big A can go together, big A, little a, or a little a. So it looks like only this one here, so that's 1 out of 4. That's 1 out of 4, or you could say 25%. Both of those work. Okay. So now what? Next question. What is the probability that individual 3, 2, so this is generation 3, 1, 2, so that's this person here, 3, 2, and 3, 3, that's this person here, will have a normal child. Okay, so for this one, a normal child, okay, a normal child would be a big A, or a big A, little a. And by normal, we just mean they don't have cystic fibrosis. Okay, well, this is going to be an easy question, I think, because this parent here is shaded in. It's autosomal recessive, which means all the shaded have to have little a's, which means all they have is little a. It doesn't matter how many kids they have, the parents only have little a's. So what's the chances that they have another kid here? And let's just say it's a boy. There you go. 100% chance. 100% chance that this next child will, that they'll have cystic fibrosis. What's the chances of being normal? Well, that'd be 0. 0 out of 4. Well, really it's 0. 0% chance. The parents only have little a's to give, right? Okay, well, hopefully that made some sense. This is a pretty advanced question, but it is a question you could get. Maybe try the diploma exemplars and then go back to these questions.